Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Yeah, I've shared my screen. Is it visible? My screen is visible, children?
Yes,
Yes,
ma'am.
ma'am.
Yeah. Yeah, please take the question and work it.
Ma'am,
Yeah, got it?
is it 26?
26. Yes, it is 26. Very good. Very good. Yeah. So OQ is the radius. PQ is a tangent. So this angle is a right angle. So using Pythagoras theorem, you can find OP, 5 centimeters. In the same way here, O dash S radius. O dash S radius, RS tangent, so 90 degrees. Using Pythagoras theorem, you can find O dash R, 13. Now from here to here, this is the radius of the smaller circle. From here to here is the radius of the smaller circle. We found OP using Pythagoras theorem. This is 5. O dash R using Pythagoras theorem, 13. Now from O to, let me call this point A. OA. OA is the radius of the smaller circle. So OA is 5. Sorry, 3. OA is equal to OQ. Radius of the circle, 3. Similarly, O dash A is the radius of this circle. O dash A is the radius of the circle with center O dash. And the radius is 5. So this is 5. So the length of PR is 5 plus 3 plus 5 plus 13. PR is equal to PO, which is 5, plus OA, which is 3, plus AO dash, which is 5, plus O dash R, which is 13. Okay, next one. So here you see a circle with center O. T is an external point to the circle. And from this external point, we have two tangents, TP and TQ. Circle with center O, radius is given 5 centimeters. R is equal to 5 centimeters. Radius is equal to 5 centimeters. T external point. From here, you have two tangents, TP and TQ. AB is another tangent. AB is another tangent to the circle at E. AB is a tangent to the circle at E. Given OT is equal to 13 centimeters, find the length of AB. Yeah, please try, children. I'll just give you a hint. You can take up the triangles TAE and once again, hint. Prove that TAE and TPO are similar triangles. Prove that TEA and TPO are similar. The order is not correct. Okay, so don't go by that order. The order may be right, may not be right. So I'm just mentioning the triangles. So show that these two triangles are show that these two triangles are similar. Proportion, substitute the values, and you can find AE mostly. Yeah, you'll find AE and then you can find AB. You may have to use Pythagoras theorem to find other line segments. Please try.
Ma'am,
Yeah.
ma'am, in a sample paper, I saw a question like this, where we
Yeah,
had to
darling.
where we have to prove AB is equal to half of the perimeter of the triangle.
Yeah,
Can we-
we'll do that. Yeah, I have that question with me. We'll do that after this.
Is this similar, ma'am?
No, that the figure is different. No. I think we did it in the last class, no? Didn't we?
No, ma'am.
Okay, you can, if you have the question, you can share it now. We can do it now after this. If you have the question with you, you can share the question with me on WhatsApp. We'll do it now.
Yes, ma'am. I seem to remember the figure. That's why I asked.
Not for this figure. Anyways, see, it can be a completely new situation also. So I need to see the question or the figure to really answer your question.
Yes, ma'am. I'll take a photo and send it, ma'am.
Yeah. Okay, so here OE radius AB tangent. OE radius AB tangent. So this is 90 degrees. Radius perpendicular to tangent. This is 90. So which means angle 1 is also 90 degrees. Angle 1 is 90 because this is 90. This is 90. So angle 1 is 90. Angle 1 is 90. Angle 2 is 90 because again radius OP perpendicular to tangent TP. So angle 1 is 90 degrees. See, 1 is 90 because OE is the radius. AB is the tangent. So here is 90 degrees. Yeah. So here is 90 degrees. Radius, tangent, perpendicular. So since this is straight line, when this is 90, angle 1 is also 90. So angle 1 is 90. Angle 2 is 90 again because radius OP perpendicular to tangent TP. So now take up the two triangles, TEA and TOP. TEA and TOP. So angle 3, common angle. 3, common angle. And then angle 1 is equal to angle 2. Angle 1 is in triangle TEA and 2 in triangle TOP. Both 90 degrees. So the two triangles are similar by AA similarity criterion. Write the proportion. In similar triangles, corresponding sides are proportional. So write the proportion. Now we need to find certain values, right? So I just start there. Okay, I just start there. Now we see it's enough to find AB. It's enough to find AE because these two triangles are congruent. You can prove that they are congruent. You can prove that these two are congruent. So since these two triangles are congruent, CPCT you have AE equals EB. AE equals EB. So here we have AE. See here we have AE here. So you find AE, double it, you'll find AB. So I just tried to find as much possible. So I thought we could find PT. You can just check this. You can find TP and TE. So PT using the Pythagoras theorem and TE because OT is given 13. OT is 13. OT is 13. OE radius 5. OT 13. OE 5 radius. So TE is 13 minus 5, 8. PT can be found using Pythagoras theorem. So this ratio was not used. So substitute here and find AE. Once you find AE, double it to find AB. Yeah. So how do you show that these two triangles are congruent? This triangle, the triangles which I've ticked. So how do we show that they are congruent? This angle is equal to this angle. This angle is equal to this angle because equal tangents are equally inclined to the line segment joining the center and the external point. So this angle equals this angle. Then angle 1 is 90. Okay, let me just mark. Here, this is 90 degrees in this triangle. This is 90 in this triangle. This angle is equal to this angle. And this is the common side, which is also the included side. So the two triangles are congruent by the ASA congruence criterion. So AE is equal to BE CPCT. So we found AE, double it, because AE is equal to BE. So double it to find AB. Clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. See, I've used only this these two ratios. I've substituted here. TE by TP. TE is 8, TP is 12, EA we have to find, and OP radius 5. Yeah, can I have the answer from you?
Ma'am, AP is equal to CP.
AP, yeah. AP, or we'll write PA. Okay, the
PA.
extent point is Yeah, the external point is P. So PA is equal to PC, okay?
PB is equal to PD.
PB is equal to PD.
So PA minus PB is equal to PC minus PD.
Yeah. Is equal to PC minus PD.
Which implies
Subtracting.
AB is equal to CD.
Correct. Very good. Very good. That's it. So P is an external point to both the circles. PA, PC, tangents from P to the bigger circle. PB, PD, tangents to the small circle. So PA is equal to PC. PB is equal to PD. So on subtracting, we have AB equals CD.
Ma'am, can you please show that slide for a second?
Oh, sure, yeah.
Thank you, ma'am.
Yeah. So here we have three right triangles. Now fix one triangle and prove that that is similar to the other two triangles. Now supposing you fix the small triangle, the smallest triangle, MBK. So prove that MBK is similar to the other two triangles, MOP and MAH. Fix any one triangle actually. Okay, if you fix a smaller triangle, the smallest triangle, MBK, prove that this triangle, MBK, is similar to the other two right triangles. So from them you can write a proportion. In similar triangles, corresponding sides are proportional. So using these proportions, you can get this result. Okay. So we'll do this together. So in triangle MBK, and triangle MOP. So this is the common angle. I think that part, if we don't write the similarity portion, no, if we write this, it'll look too lengthy, like as if it's very difficult or something. So let me write this straight away, because double A, common angle and then 90 degrees. So triangle MKB is similar to triangle MPO by double A similarity criterion. Now let's write the proportion. MK. Now I think it's convenient to use letters, children. Okay, so let's call this A, B, C. AO is the radius, so let's use R. This is also R, and this one is D. All right. Yeah. Okay. So since we have to prove AH plus BK, AH, which we have marked C, plus BK, which we have marked A, is equal to AB. So we have not marked anything on MH. On MH, we'll see if needed, we'll mark. We have not marked anything on MH because we don't need any part of MH here in the result. See the result? AH, we have marked C. BK, A. AB, AB is here. R. So we'll not use this side, meaning MH. We'll not use any line segment on MH. So we have marked these line segments AH, OP, and BK, ABC, RR, and D. We've completely ignored MH. Okay, now write the proportion MK. MK by MP equals, where is MK? MK. Okay, we'll not use that actually. We'll not use that. MK by MP equals KB by PO equals MB by MO. All right, we'll not use this. KB, what's KB? Help me, children. A by PO, B equals MB, D by MO, R plus D, R plus D. Now, since we have taken the smallest triangle as a common triangle. Okay, let me not do that here. I'll leave some space here, children. I'll leave some space here. We need to work something, but if I do that now, it'll be like why. Now it's difficult to answer that question why. So let me leave some space here. We'll prove that the next set of triangles are similar. So triangle MPO similar to triangle, not MPO, sorry. We fix the smallest triangle, no? So triangle MKB similar to triangle MHA, double A. So MK by MH equals KB by HA equals MB by MA. In similar triangles, corresponding sides are proportional. We'll ignore the ratio where we have line segments of MH. So this MK, MH, yeah, this one we'll ignore. Okay. So KB is A by HA C equals MB D by MA. MA is, what's MA, children?
D plus 2R now.
D plus 2R, yeah, or 2R plus D, 2R plus D, 2R plus D. Now, children, we'll do one more thing. Now, what is A? Now, we need to prove this result, right? AH. What is AH, children? AH is what? C, right? C plus BK is
A, ma'am.
A equals AB.
2R.
2R. So in the result, you need AH is how much? AH is C BK. BK is A and AB is 2R. Right. So this is what we have to prove. C plus A is equal to 2R. So you need only CA and R. CAR. Where is C, CA and R? All right, yeah. So now what you have to do is, in both the, apart from CA and R, what is common to both the proportions? See, check this one and this one. Check these two. We need, yeah, we need C, A, and R in the final result. Okay, so we need C, A, and R in the final result. Leave them. Apart from them, what is common in both these proportions? Somebody said D. So what you do, use the two proportions and write the result like this. D is equal to something. So you will get D is equal to something from here. D is equal to something from here. So now when you equate this and this, you will lose D. You will lose D. See, you don't want D in the result, right? You only need C, A, and R. In fact, you don't want B also. There is B here. There is B here. You don't want B. So we'll see. Mostly we'll lose B when we work it. So what I said is we need C, A, and R in the final result. Apart from C, A, and R, D is common to both the proportions. So write this one as D is equal to something. Here also D is equal to something. And now equate these two. So mostly when you do that, you should get this result. C plus A is equal to 2R. Try, children. Please try. Cross multiply, and write D is equal to an expression from both and equate that and see if you're getting this result. Yeah, actually, I was just wondering how we are having B. So see, I didn't notice that, meaning I didn't realize that. See here, children, B is nothing but R. That's what I was wondering, like, how do we get rid of B? B is nothing but R, children. Yes or no? Are we there?
Yes, ma'am.
Yeah, so that's what I'm wondering. Like, you shouldn't have that. So that's what I told you. So maybe when we work, we'll get rid of it. But I was just wondering, how can you get rid of B? So that's what it is. You should. That is not. You don't have to take that as B. It's R. OP. Radius. No, it's R. So this is R. Yeah. So now we'll conveniently get the result. Okay. So here we fixed a small triangle MBK. We proved that MBK is similar to the other two triangles, MOP and MAH. So from these two, we write the similarity, the proportion. And it's convenient to go ahead with variables than with the line segments like this KB, PO, MB, MO. It's convenient to use variables. So we marked off the line segments, right? So OP, I had first marked B, and later I realized that it can be taken as R because it's a radius. Okay, so we have marked A, R, C, and D. So use them in the proportion here and here. Use them in the proportion here and here. Now look at the two proportions. See what you have in the final result. You need C, A, and R. In the final result, you need C, A, and R. Now look at your proportions. Look at your proportions. C, A, and R. You need C, A, and R. So A, R, D is not needed. Here, C, A, R, D is not needed. So apart from C, A, and R, you need the letters. You need the variables C, A, and R in the final result. Apart from C, A, and R, that variable which is not needed is D. You don't need D. So what we do is we use this proportion, we cross multiply, and we write an expression for D. D is equal to something. We do the same thing with this proportion. D is equal to something. So how do we do that? We cross multiply. And we gather the D terms on one side. So RD minus AD, these two terms have D. Gather the D terms on one side. RD minus AD. Then take out D common. There are two terms with D. Have the D terms on one side. Take out D common. And then D is equal to AR by R minus A. In the same way, in the second one, cross multiply. Now we have AD and CD. These two terms contain D. AD, CD. So have AD and CD on the same side. Then take out D common. And we get D is equal to 2AR by C minus A. Equate these two. We have two expressions for D. D is AR by R minus A. D is also 2AR by C minus A. Both are expressions for D only. So equate them. On equating in the numerator, AR gets cancelled. Cross multiply. And yeah, you get C plus A is equal to 2R, which is nothing but AH plus BK is equal to AB. Okay, so in my diagram, BD is 30 centimeters, DC is 7 centimeters. It's definitely not proportional, but don't mind that. BD is 30, DC is 7, but both of them look equal. So don't mind that, okay? So BD is 30, DC is 7. And yeah, radius. Find R. The question is find R. So you can prove that OEAF is a square because it's a rectangle, and in the rectangle, adjacent sides are equal. Adjacent sides OE and OF, they're equal. In a rectangle, when adjacent sides are equal, it's a square. Angle E is 90 because radius perpendicular to tangent. F is 90 degrees, same reason, radius perpendicular to tangent. Angle A is 90 degrees given. So the fourth angle of the quadrilateral will also be 90. Three angles are 90 degrees. So the fourth angle, 360 minus 270, 90 degrees. So in the quadrilateral OEAF, every angle is a right angle. So it's a rectangle. And in the rectangle, adjacent sides are equal. OE is equal to OF. So OEAF is a square. Now these, you know, BE is equal to BD, tangents from the external point B. So if this is 30, this is also 30. Then CF is equal to CD, tangents from the external point C. So if this is 7, this is also 7. So AB will be R plus 30. AC will be R plus 7. And BC is equal to 37. So connect the sides using the Pythagoras theorem. Connect the sides using Pythagoras theorem because it's a right triangle. That's all. Now you need to work this and find the value of R. Yeah, please work this and give me the value of R. With this, we'll wind up the session for today. Please work this. Expand using a plus b the whole square. A square plus b square plus 2ab. Don't forget 2ab. Yeah, got the value of R. Yeah. What's the value of R, children? Okay, children, use the emoji, raise your hand. Abhya, Madhumita, Florentina, Danya, Sashank, Raja, Krishmi, and Krishrutik. Very nice. Okay, do you want me to work this or we'll see the answer tomorrow, children? Would you like to complete it yourself?
Ma'am, we'll see the answer.
We'll see the answer now?
Yes, ma'am.
Okay, yeah. Let me do it. So, a squared plus b squared plus 2ab, 60r, plus a squared plus b squared plus 2ab, 14r, is equal to 37 square, children. What is 37 square?
1369.
1369. Okay,
Yes,
I don't know. Somebody said 1369. Okay. So r square plus r square is 2r square plus 60r and 14r is 74r and 949 is 949 is equal to 1369. So 2r square plus 74r plus 949 minus 1369 is equal to 0. So somebody tell me.
ma'am, 420, ma'am.
420. Thank you so much. So 2r square plus 74r minus 420 is equal to 0. Now divide by 2 throughout. So r square plus 37r minus 210 is equal to 0. You'll have to split the middle term now. Split the middle term.
30 and 7.
Sorry?
30 and 7.
Oh, 30 and 7. And 7, how do we need to get a positive 37 and negative? No, how will 30 and 7 work? No. No, children. 30 and 7, you cannot fix the signs to get minus 210 and plus 37. Not 30 and 10. Not 30 and 7. 30 into 7 is 210. But you need to get minus 210 and plus 37. So tell me, how is that possible with 30 and 7?
I'm 42 and 5.
40 to 5.
42 and 5. Okay. Second. Forty-two and 5. Yeah, correct. Yes. Very good. 42 and 5. Or you can use the quadratic formula. See, if you're not able to split the middle term, just use a quadratic formula. Okay, let's do it using the quadratic formula. So R is equal to, because you're finding R, no, so R is equal to minus B, minus 37, plus or minus square root of B square, 37 square, minus 4AC, 4 into 1 into minus 210. 4 into A into C. So it'll be plus 840. Plus 840 by 2A. 2. So this is negative. So this is negative. R cannot be negative. So R is equal to 10 by 2, 5. 10 by 2, 5. Radius is equal to 5 children. Anyone wants me to show any particular slide? Okay. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, children. Good night. Thank you.
Thank you.
Thank you.